Welcome. So in this lesson, what we're going to be doing is comparing fractions. That's what we're going to be doing, comparing fractions. So let's begin with our first dot point here, which tells us if the denominators are the same, the fraction with the bigger numerator is larger in size. So let's look at this first example here. And can I get you to highlight the fact that, here we've got 3 on 10. So we've got a 10 as our denominator here. And here we've got 7 on 10. So we've got 10 as a denominator here. They both have the same denominator. So what I've done just to kind of represent both of these fractions, because they've both got the denominator of 10, I've taken a circle and I've broken it up into 10 pieces. I've taken a circle and I've broken it up into 10 pieces because the denominator is 10. So if I have 3 on 10, what it's saying is that I have 3 of these pieces. So let's color that in. So I've got 3 of these pieces, 3/10. So there's 1/10, there's 2/10, there's 3/10. So there it is. There is 3/10 that I've shaded in. Quite ugly, but there you go. If I have 7 on 10, well, as you can see, I've got my tenths here. I need to shade in 10 of them. Now, this is going to be a bit harder. I need to shade in 10. So there's 5 that I've just shaded in. And then I need to shade in 2 more. There's 10. Now, it's pretty obvious, isn't it? Which one is bigger? This one or this one? Well, clearly this is the bigger fraction. 7 on 10 is bigger. Because, all these pieces are the same size, aren't they? They're tenths. So here I only have 3 of the tenths. Well, here I have 7 of the tenths. This one is clearly bigger. So you make sure that your inequality is eating the bigger number. That's how you draw in your inequality. It has to be eating the bigger number. So just to reiterate, when the denominators are the same. So here you can see the denominators were the same. The fraction with the bigger numerator, this had the bigger numerator, 7, is larger in size. So when the denominators are the same, the one with the bigger numerator is larger in size. So that's why 7 on 10 was bigger than 3 on 10. Let's now go on to the next one. Okay, the next one says, if the numerators are the same, the fraction with the smaller denominator is larger in size. Oh boy. All right, so first thing I want you to take note of is for these two fractions here that we're comparing, we've got 4 on 9 and we've got 4 on 5. So the numerators are the same. So what I've done is, well, I've had to do something a bit different here. Let's have a bit of an analysis here. Do you see how this is a 9? That means I've taken my circle and I've broken it up into 9 pieces. 1, 2, 3, 4, 5, 6, 7, 8, 9. And now I've got 4 of these 9 pieces. I've got 4 of these 9 pieces here. So let's shade that in. All right, so there's 1/9, 2/9, 3/9, 4/9. All right, there's 4/9 right there. Now, if we come over here, do you see how I've got a 5 here? So that means I've taken my circle and I've broken it up into 5 pieces, and now I need 4 of these. All right, so I need 4 of these pieces now. So let's shade that in. So there's 1/5, 2/5, 3/5, 4/5. Whoa, that's pretty ugly, but hopefully you get it. I've shaded in 4 of them, so that's 4/5. Now, if I was to ask you, which represents a bigger size, this or this? Well, clearly this is bigger, isn't it? This is much bigger. So that means it should be facing that way, my inequality. It has to be eating the bigger number. Now, let's really analyze this for a second and really appreciate what's happened. The reason why this is bigger is because the pieces, if I just rub this out for a second, do you see how the pieces are much bigger than on this side? So I have 4 bigger pieces. Here I still have 4 pieces, but the pieces are much smaller. So that's why when your numerators are the same, the fraction with the smaller denominator is larger. So do you see how this is a smaller denominator? This is smaller. Because it's a smaller denominator, it means that my circle has been cut up into less pieces. So each of those pieces are bigger. So therefore, the one with the smaller denominator is going to be larger in size. That's what you really have to take home here. The one with the smaller denominator, when the numerators are the same, is going to be bigger. Because as you can see, if I shade in these 4/5 here, this is much, much bigger. And that's opposed to what was happening up here. Up here, because the denominators were the same, that means all the pieces were the same size, right? All the pieces on both of these sides were the same. So therefore, it was simply a matter of which has the bigger numerator, because, here you got 7 of these tenths, when here you've only got 3 of these tenths. So that's really the thinking that goes on behind this. So there's a little explanation. We'll take a break and then we'll jump into this.